Good afternoon, everyone. Today is Friday. Happy Friday, October 28th. So today you have a quiz about 4.1 to 4.6. Are you able to see the quiz in Blackboard? Okay, so please do the quiz before midnight. Yay. Okay. And please continue to do your homework. Our second set of homework assignments from session 3.5 to 4.7 is due on Monday. Okay, and Monday we will also Monday. This weekend I will try to grade your quiz. Okay, and then we can talk about the quiz mistakes on Monday. Hi, and Wednesday we have a review session at 8 p.m. Right, everybody? So join the TED Live. You can ask me your homework questions or practice exam questions. Okay? So please do the practice exam multiple times. And make sure you understand every problem on the practice exams and also the steps on your practice exam. Okay, everybody? Yes. So the review session is on Wednesday, 8 p.m. virtual. So join TED Live. And I will also make the recording. And when is our exam? Friday. So our exam is gonna be from 12:20 to 1:50, right? So I want to give you more time. And if you cannot come early on Friday and you want the 1.5 hour opportunity, you can email me. We can schedule the makeup exam before our class exam time. Okay, maybe on the Thursday. Okay. Yes, everybody. So from last time, I know most of you are okay. Just 4 of you have a class before us on Friday. So for those 4 of you, if you cannot come early but you still want to have the 1.5 hours, please email me, okay? To schedule the makeup exam on Thursday. Yeah, so take it on Thursday. Okay, so that is our plan. So today we will continue to finish 5.1 and we might start a little bit of 5.2. And if you have questions, please feel free to email me and or you can put it on the website. So this questions file, you can print screen your questions and post it there. And then we can go over together. Okay? And so besides my office hours, you can email me. We can meet virtually in the evening. And also, tutor. So we have free tutoring service in the Office of Student Success. And Noah Smith is very good tutor. I think he's the tutor assigned for our course Precalculus. Okay, so Noah Smith is a very good tutor. Okay, so get all the possible help you're able to. Okay. All right, so last time we talked about angle, complementary angles. What's complementary angles? You add them up, you get how many degrees? 90. Supplementary angles, you add them up, you get 180, right, everybody? And then last time we were looking at this problem. We want to find the measure of the smallest angle formed between the hands of a clock reading 2:38. So we know 1 hour, because one rotation is 360 degrees, and we have 12 hours. So each hour has 30 degrees. And 1 minute, because we have 60 minutes, therefore 360 over 60 is 6. 1 minute corresponds to 6 degrees. Do you remember that, everybody? So let's look at the minute hand. Okay, so the the minute hand is at, okay, so because it's 38 minutes, so we use 30A, and then we multiply by, because each minute is 6 degrees. Is that okay, everybody? This is not 38.6. How about, let me just use a little course. Okay, multiply. Not x, multiply. Okay? What's 38 times 6? Use your calculator. Thank you, 228 degrees. Okay, so this is the angle from 12 o'clock up to the 38 minutes. So this is 228 degree. So far, so good, everybody? Yeah, so this is past the 12 o'clock. So that is the minute hand. Okay, how about the hour hand? Bless you. The hour hand is right here. Okay, it passed 2 o'clock. Okay, we want to compare with the 12 o'clock. It passed 2 o'clock. So this is 2 hours. Each hour is 30 degrees. And 2 hours is 60 degrees. Right, everybody? And then, okay, do you see this portion? This portion is, so from 2 o'clock to 3 o'clock, this is 30 degrees. But this portion is 38 over 60. Right? You kind of divide 2 o'clock to 3 o'clock into 60 pieces. And now we're at 38 minutes. So that's why our hand is 38 over 60, okay, of 30 degrees past 2 o'clock. Okay, so that's why 38 over 60 times 30 degrees plus 2 o'clock. 2 o'clock is 60 degrees. Right, everybody? Yes? So we're looking for this guy. From 12 to this hour hand. It passed through 2 hours. That's 60 degrees. Plus, this is 1 hour, 30 degrees, but this portion is 38 over 60. Right, everybody? Bless you. Okay, let's calculate. You see 30 and 60, we can cancel, we get 2. What's 38 over 2? Is it 19? Plus 60 is 79 degrees, right? Past 12 o'clock. Okay, this is 79 degrees. Okay, we have this angle from here to here is 228 degrees. And then this angle from 12 o'clock to this hour hand is 79 degrees. Then what's the angle between them? Okay, so the angle difference, the angle between the two hands equals, use the bigger angle, 228 degrees minus 79 degrees. What do we get? 149 degrees. Very good. So far so good, everybody? So I can give you any time. Then you can use similar steps to find the angle between the hour hand and the minute hand. Yes, everybody? Ooh, attendance. Okay. Yes. So we first figure out the mini hand angle, and then we figure out the hour hand angle, and then we compute the difference between the angles. Okay. Any questions about this example? All good? Mm-hmm. Let's continue. Okay, radian measure. So have you heard of radian and degree? Yes? Okay. Your calculator, there is a mode. Oh, where is it? Oh, okay. Degree. Oh, yes, degree and oh, okay. So if you use this kind of calculator, do you see DRG, the second button in the first row? That's degree. Okay, DRG stands for degree. So you click that, and then you see, oh, DEG is degree, RAD is radian. Okay. So when we compute angle or later we learn about trigonometric functions, it's very important you're using radian or you're using degree. Okay, you get completely different answers. So be careful. What is radian? So radian measures of angle is preferred because the radian measure of a central angle in a circle is the proportionality constant between the arc length intersect by that central angle and the radius of the circle. So this is this S. This is the arc. Okay, this is the arc. Arc length is S. So radian is defined such that uh, theta equals S over R. Okay, so the angle is the ratio of the length of the arc, okay, and divided by the radius. So this is very important. So this implies that there are 2 pi radians in a full circle because the arc length around the full circle is the circumference. So C equals 2 pi r. Do you know that for circle, okay, for any circle, area equals pi r squared. So circle with radius r, okay? Area is pi r squared. And then the circumference equals 2 pi r. Okay, therefore the angle. So one circle, the angle is 360 degrees, but in terms of radian, that's the circumference over the radius. So r and r cancel, we get 2 pi. Okay, everybody? So radian of a full rotation circle is 2 pi. So 2 pi is equals to 360 degrees. So this is how we convert between the units. Radian measure allowed us to treat the domain of the trigonometric functions. We'll learn that in later, okay, as real numbers rather than as angles. Okay, so radians, we have numbers instead of just angles. Oh, thank you. Okay, definition of radians. An angle with its vertex at the center of a circle that intersects an arc on the circle equals to in length to the radius of the circle has measured 1 radian. So if theta equals to 1 radian, that means this arc length, okay, this arc length equals to the radius. Okay, this is what it means. So if the radius is 1, then the angle theta is 1 radian. It means this arc length the length of this arc is also 1. Okay, everybody? So that's the definition of radian. How do we convert between degrees and radian? We know 360 degrees equals 2 pi. And you can divide both sides by 2. Then we know pi equals 180 degrees. Okay? So this means 180 degrees over pi is 1, or pi over 180 degrees equals 1. So if you want to convert from degrees to radian, you multiply by pi over 180 degrees. If you want to convert from radian to degrees, you multiply by 180 degrees over pi. The feeling is like you work with physics and chemistry, right? And then you work with the unit convention. So let's say if you have 2.7 meter, how do you convert it to centimeter? Well, you have the unit is meter, right? How to convert into centimeter? You want to get rid of the meter, right? You want to get rid of the meter. That's why you put your meter downstairs so you can cancel that. And you want to convert from meter to centimeter. So you put centimeter on top. And then you think about 1 meter is how many centimeter? 100 centimeter, right, everybody? And therefore, we cancel the m, and then we get 2.7 times 100 is 270 centimeter. Yes, everybody? Right. Okay. So how do we convert degree to radian? It's kind of similar. Okay, so we'll do some example later. Yeah. Okay, if no unit of the angle measure is stated, then the angle is understood to measure in radian. So for degree, you see this little circle up there. If you don't see this little circle, it means it's measured in radian. Okay. Example, in the picture on the right, the angle is understood to be radian. And here, this is the degree. Okay, so how do we convert? Well, think about 135 degree. We have degree, right? So we want to get rid of the degree and we get radian. So, and then we think about pi, okay? 180 degree equals pi. So therefore, if you want to cancel the degree, you put the degree symbol in the denominator. And you know 180 degree is pi. Yes, everybody? So degree cancel. And do we have common factor? Let's see. We have 45 degree, right? We have 45 degree as common factor. So 180 is like 45 degree times 4. Yes, everybody? 135 is like 45 degree times 3. Therefore, the 45 degree cancel. We get 3 pi over 4. Is that okay, everybody? So this is how to convert from degree to radian. How about from radian to degree? So you have 3 pi over 4. You want to get degree, so you put the degree on top. Once you put the degree, then you know 180 degree equals pi. So we put 180 degree, that equals pi. Yes, everybody? And do you see the pi cancel? And 180 divided by 4 is 45. So now it's kind of slow here because of the internet. So now 3 times 45 equals 135. Now we have a degree. So this is how we convert from degree to radian and then from radian to degree. Okay, everybody? Awesome. So let's keep going. Practice. State the radian measure of all the multiples of 30 degrees and 45 degrees going around a circle using the notions of these angles as a fractions of a full circle. Okay. We start with the positive x-axis. The positive x-axis is always the initial side of the angle. So that represents angle 0. Okay. So in radian is 0, in degree is also 0 degree. Okay. So this one, 0, radian 0, degree is also 0. So far so good, everybody? That's why I hope you can print out your notes, because then you don't need to draw the circle on your notebook. Do you know that every semester you get $100 for printing costs? If you don't use it, you will lose it. Your money roll over. So please print out the worksheets. So I recommend you to print out like all the remaining worksheets from the semester, right? And you can put them in binder, yeah. And then each class you just take that worksheet and then you can take notes on that worksheet. After you get home, you can review the worksheet and see if you can remember those. And then you can look at your worksheet to do your homework, right? If you have questions, put a question mark and write down your questions and then ask me. So I really hope that you can develop the study habits of learning math. Okay, learning math is very important to take notes because when I write on the notes, those are the things I teach. But when you take notes, those are the things you learn, right? Okay. And I hope, so for maybe some of you, this is your last math class. And maybe for some of you, you need to go to Cat 1, Cat 2, and higher math classes, right? So it's very good to have a good habit. And I can tell you all of my higher math classes, everybody would ask me to take notes, okay? So I hope you can develop this study habits. Oh, by the way, in the spring semester, I will teach Calculus 1, and my section is in the afternoon, 2 o'clock. I think right now I have 22 students already enrolled. The maximum size is 26. So 4 more spots. Okay. I hope to see some of you next semester. All right. So we keep going. You know, a right angle is 90 degrees, right? And then 30 degree is what? 1/3 of 90 degrees. So here this is 90 degrees, and you cut it into 3 pieces, right? So that's why this corresponds to 30 degrees. Okay, so this is 30 degree, and 30 degree is pi over 6. Think about it, pi is 180 degrees. 30 is 180 divided by 6. That's why 30 degrees is pi over 6. Okay, let's do all the multiple of 30 degrees. Okay, so this is 30. Now you see this one is what? Let's do the multiple of 30 first, and then we do the multiple of 45 later. Okay, because that would be easier. So same angle, okay? And then you see is this guy. 30 plus 30 is 60. So this 60 degree. is like 2 copy of 30 degrees. Do you agree? So 2 copy of pi over 6. So 2 copy of pi over 6. Oh, do you see 2 and 6 cancel? We get pi over 3. So pi over 3 is 60 degrees. And then next one, this is 90 degree. And that is pi over 2. Because 180 degree is pi. So 90 degree is half of pi. Okay. And 90 plus 30 is what? 120. And that is, well, you think about, this is like pi over 2, and then you add pi over 6. Right, everybody? So you can think of, oh, this is pi over 2 plus pi over 6. You see the common factor is 6. Right? And pi over 2, this is like 3 pi over 6. So 3 pi plus pi is 4 pi over 6. Something wrong here. Okay, 4 pi over 6, which is 2 pi over 3. So 120 degree is 2 pi over 3. Okay, everybody? And then we keep going. We get what? 120 plus 30 is 150 degree. And that is, you can think of 4 pi over 6. And then you add another pi over 6. You get what? 5 pi over 6. Yes, everybody? Okay, 5 pi over 6. And, oh, see, 180 is pi. Yes, everybody? Keep going. What's 180 degree plus 30? 210. And you can think of, oh, pi plus pi over 6. Yes? So this is like 6 pi over 6, or plus pi over 6. So that is, how many pi over 6? 6 pi plus pi. 7 pi over 6. Yes, everybody? Okay, keep going. When we add 30 degree, what do we get? 240, right? And see, you increase the number of pi. So next one will be 8 pi over 6. Yes, everybody? 8 pi over 6, which is 4 pi over 3, right? Okay, and then 240 plus 30 is 270 degree. And this is 3 pi over 2. Very good. When we add 30 degree, we get what? 300. That is 5 pi. How many? Yeah, very good. 5 pi over 3. You can think of this. This is 7 pi over 6, 8 pi over 6, 9 pi over 6, then 10 pi over 6. Yes, so 10 pi over 6. Yeah, 10 pi over 6. We divide it by 2. We get 5 pi over 3. You see the pattern? Okay, how about this angle? 330. This is 10 pi over 6, and this is 11 pi over 6. Yeah. Okay. Oh, by the way, sometimes you might see my pi is in the numerator. Sometimes you might see my pi is outside. They are the same. Right, everybody? Yes. Okay. Right. And we add more 30 degree, we get it back, right? So we get back, this is 360 degree, and that equals 2 pi. Right, everybody? So these are all the angles of multiple of 30. Now let's do multiple of 45. Yeah? You know, 45 is a half of 90 degrees. Yeah? So this is 90 degrees, and you divide it by 2. It's right here. Yes, everybody? So this is 45 degree, and that is what? Half of 2 pi over 2, then that is pi over 4. Is that okay, everybody? Mm-hmm. And then, at 45 degrees. Oh, do you see pi 90 degrees? Pi over 2 right here. Yes? And then you add 45 degrees, you get 135 degrees. That is 3 pi over 4 exactly. And we just talked about that, right? And then we add 45 degrees, we get 180. We add 45 degrees, we get 225. So 225 degrees. And that is, what's pi plus pi over 4? 5 pi over 4. Very good. And then we add 45 degrees. We get 270. Yes, we already have that. We add 45 degrees. We get 315. So 315. That is, yes, 7 pi over 4. Okay, because this is 5 pi over 4, this is 6 pi over 4, then this is 7 pi over 4. And then, 8 pi over 4 is 2 pi. Yes, everybody? Mm-hmm. So this is how we complete the whole circle. So these are the common angle. Okay. Yes. So I hope, trig, because we only have 5 weeks for trig, and we learn a lot, and there are so many things you gotta memorize. So I hope every day what we learned, please try your best to digest and memorize. So today, make sure you remember all those special angles. Okay? So then I tell you, okay, 225 degrees. You can remember where this angle is. So, this is the first quadrant. Your first quadrant, your angle is between 0 to 90 degrees. In second quadrant, the angle is between 90 to 180 degrees. And your third quadrant is from 180 degrees to 270 degrees, right? And then your fourth quadrant, 270 degrees to 360 degrees. Okay, everybody? So this is quadrant. 1, 2, 3, and 4. So make sure you can memorize these angles, special angles. Okay, now exercise. Convert to radian. Okay, so we want to get rid of the degree. So 108 degree. Get rid of the degree. So which means we put the degree downstairs, right? Now you know 180 degree is pi. Yes, everybody? And then, how do you simplify? So, everybody take out your calculator. If you use 108 divided by 180, will your calculator give you fractions? Yes? No? Okay, if you don't, there's a button. You click this again, it will give you fractions. Okay? we want to have fractions. So do you know how to do fractions? Yeah. For the enter, I guess. Yeah, please figure out your calculator and use fractions. Yeah, make sure you know how to get fractions. Okay, so we prefer your answer is in the fraction form, not bunch of decimals. So you get 3 pi over 5. Yes, everybody? Make sure you know how to use your calculator. Okay, continue. Negative 228 degree. Get rid of the degree. So 180, and then pi. Use your calculator. 228 divided by 180. What do you get? What does your calculator tell you? 19 over 15 pi. Yes. Okay. So this is good. I prefer if you can express your answer as fractions times the pi. That's good because this answer is exact. So don't give me a bunch of decimals. That's not exact. Okay. How about this one? So 457.89 degree and multiplied by pi divided by 180 degree. Okay, this number, there's no way you can get a fraction. That is okay. Just give me, in this case, you can give me decimals. 3 decimal places. What do you get? What's the next digit? 6. So then we round up. Okay. 99166. We round up to 992. Okay, everybody? So I hope all of you can understand the requirements. If you can express as a fraction times pi, do that. If you cannot, then give me a decimals. Okay, continue. Convert to degrees. Okay. So 11 pi over 12. We want to have degree. So you put the degree upstairs. And you know 180 degree is pi. Do you see we cancel the pi? Now use your calculator. 11 times 180 divided by 12. What do you get? 165 degree. Okay, everybody? So please make sure you have your calculator. Please bring your calculator from now on. When is our exam? Next Friday. Will you have calculator next Friday? Yes. Promise? Yes. Because some of the problems ask you to solve equations. They ask you to find the exact answer and also the decimals. So if you don't bring a calculator, you will lose some points over there. So please get your calculator prepared. Yeah. Okay, and then let's convert to degree. Minus 7 pi over 6. 180 over pi. Pi cancel. Put this in your calculator. What do you get? Thank you. Negative 210. By the way, what does negative angle means? So positive angle you go counterclockwise. Negative angle you go clockwise. Right, everybody? So we go clockwise for 210 degrees. Yes. Okay. And convert to degree. So not all the radian has pi. This one, you don't see a degree, even though it has no pi, it's still in radian. Okay, everybody? So we use 15.292 and we convert to degree. So 180 degree over pi. Now, give me 3 decimal places. Sorry, again? 8. Thank you. Degree. So far, so good, everybody? Okay. By the way, in your homework, Mobius homework, if you see something like 15 degree, 23 minutes, and 41 seconds, you know, degree is so small. 1 degree is like your whole circle. You divide it by 360 pieces. So 1 degree is super tiny, right? And now, if you see this notation, you divide 1 degree into 60 pieces. This is called minutes. Yes, you have 60 minutes in 1 hour. So this means, okay, so if you want to convert it into degree, that's 15 degree, okay? Like 15 degree plus 23 over 60. So you divide 1 degree into 60 pieces. That is minutes. And this is 23 minutes. And then second, how many minutes? How many seconds in 1 minute? 60. Therefore, this is 41 over 60 seconds, 60 minutes. You multiply 300, 3,600. Is that okay, everybody? So, yeah, this means this many degree. Okay? So, you add them up, you get decimal. Oh, tell me, what do you get? Give me, how about 5 decimal places? You get 15 point, give me 5 decimal places. Oh, 16? Oh, sorry, what do you get? 15 points. 39472 degree. So this is how to convert degree, minutes, seconds to decimal degree. Is that okay, everybody? Yeah, so you might see that notation in your Mobius homework. Okay, very good. All right, let's continue. At length. So we talk about radian. It's the ratio of the arc length and the radius. That's why arc length equals radius times the angle measured in radius. That's why it's very important to convert the degree into radius. Then you can calculate the length of the arc. Right, everybody? Okay. So let's see. Practice. Find the arc length intercepted by the central angle of 38.2 degree in a circle of radius r. So radius r is 15.8 centimeters. Okay, so this is the angle. Angle is 38.2 degree. We want to convert it into radian. So what do? Get rid of the degree, right? Yeah, pi over 180. And my recommendation, don't plug in your answer here. Use your calculator at the last step. Okay? So leave it like that. So degree cancel. So 38.2 pi over 180. Just leave it like that for the theta. And then you want to find the arc length. Arc length is theta times r. Now you put down your theta. 38.2 pi over 180. And now r. What's r? 15.8. Yes, everybody? Now you can plug in your calculator. Give me 3 decimal places. So you only use your calculator in the last step. Then your answer will be more accurate. So plug in your calculator. What do you get? What do you get, everybody? Yeah, so type into your calculator. What do you get? 3.35. Missy, do you multiply the pi? So do you know your calculator? There is a pi symbol, so you can multiply that pi. Yeah, everybody plug in your calculator. Yes. So do you get 10.534? Yes? Okay. Make sure you get the same answer. Okay? Because sometimes I have students in the exam ask me, how do I type this in your calculator? In the exam, I cannot answer that question. In the exam, I can only answer question about the question. So if you don't understand the question, I can explain to you and make sure you understand. But I'm not able to look at your word and say whether it's doing right or wrong, or what formula, or how to use the calculator. So please make sure you know how to use your calculator now. Okay. Okay, second question. A rope is wooded around a drum of radius 0.327 meters by rotating the drum through an angle of 132.6 degrees. Oh, by the way, last questions. Our unit is cm. So this is a math class. If you remember to write on the units, that's great. If you forget to write on the units, I won't take your points off. But it's only for my class. Your chemistry class, if you forget the units, you might get points off. Okay? So only for my class. I try my best to write on the units, but if you forget, alright. But don't tell your chemistry professor, say students that it's okay. Okay? just in this math class is okay. But your other class, yeah, listen to your instructor. Okay. So yeah, radius is our angle theta, right? We want to compute the length of rope. Okay, so theta is 132.6 degree. Do the similar thing, right? Divided by 180 degree and multiply by pi. Do you see degree cancel? 132.6 pi over 180. Do we put this in our calculator now? No. Yeah, so we plug in the last steps. So at length is theta, which is 132.6 pi over 180 times r. What's r? Yeah, 0.327. Okay, now you can plug in your calculator. What do you get? 0.756. 0.75. What's your next digit? 7. Oh, so if yeah, round it up. Right. If your next digit is greater or equal to 5, you round up. If your next digit is less than 5, so less than or equal to 4, we round off. Okay, everybody? Yes? Good. What's the unit? Meters. Yay. Okay. Good. All right. Now we keep going. Think about a point moving around a speed of radius r at a constant speed. So let's say this is rotating. Okay? Linear speed. Have you taken some physics class? Talk about linear speed and angular speeds? Probably yes or probably not. It's okay. So linear speed is the rate of change of the distance per unit of time. We know speed equals distance over time. Yeah? Or you can think of what's the unit for speed? What's the unit for distance? What's the unit for time? So maybe for distance, if we use meter, and maybe the time we use second, then your speed unit is meter per second. How about if distance, miles, time, hours, then your speed is miles per hour. Right, everybody? So you can see from the units whether it is speed, distance, and time. So angular speed is the rate of change of the angle per unit. So that's why omega looks like a W, but it's a Greek letter omega. So say it, omega. Omega equals theta over t. Okay? Theta, yeah? Theta over t. The angle divided by time. Okay, then there is a relationship between angular speed and linear speed. Because S, yeah, the S equals theta times R. So V equals distance over T is R times theta over T. You can pull out the R. Theta over T is the omega. So linear speed equals R times angular speed. Right, everybody? Mm-hmm. Okay, let's look at example. An object goes around a circle of radius. When you see radius, oh, we know that is R. Every 3 seconds. See? That's the time. Right? So when you read a problem, write down the math symbol. Find its angular speed and linear speed. Okay. It goes around a circle. So every 3 seconds, it goes around one rotation of the circle. Do you agree? What's one rotation of the circle? 2 pi. Yes? So 2 pi. Therefore, angular speed equals the omega is the angle over time. What's the angle? 2 pi. What's the time? 3. Yes, everybody? Okay. What is the unit? What's the unit? Oh, sorry. What's the unit of angle? Questions. For linear speed, it's meter per second because the distance we have the meter. But for angular, do you see the numerator? It's radian. So that's why the unit should be radian per second. Yeah, so that's the unit of the angular speed, radian per second. Okay, how about linear speed? So V is, right, it's S over T. S is the distance, but for arc length, it's theta times R over T. What's theta? 2 pi, right? R, 1.25. T, 3. Right, everybody? Okay. 2 times 1.25 is 2.5, right? Yes. So this is 2.5 T pi over 3. Okay, plug this in your calculator. What do you get? Give me 3 decimal places. What? 2.618. Yes. What's the unit? Meter per second. Yes. Your linear speed has units meter per second. Okay. Your angular speed has units radian per second. So far, so good, everybody? So make sure when you calculate this angular speed or at length, we use radian. Don't use degree. So convert the degree to radian. Okay, now the blades of a wind turbine, okay, are 116 feet long. Ooh, so let's draw the picture. Okay, something like that, right? Okay, well, this is a wind turbine. Okay, the blade is 116 feet long. This is like what? The radius. Do you agree, everybody? Is this your first semester here? Oh, good. Before we have this extension of the summer building, we used to have a winter here. Now, yeah, we remove that and do this extensions. Right. Okay. And then the propeller rotates at 15 revolutions per minute. Okay. So this is what? This is the how? So 15 revolutions. 15 revolution. One revolution, how many angles? One revolution is 2 pi, right? Oh, so what's that? 30 pi. Yes, everybody? So part A, angular speed. So angular speed, the omega, equals theta over t. Theta is 30 pi per minute. It's already per minute. Yeah, over 1 minute. So that's why it's 30 pi. And what's the unit? The unit radian per minute. Is that okay, everybody? That's the angular speed. And then part B, what's the linear speed? Linear speed is theta r over t, right? So theta 30 pi, what's r? 116. T is 1 minute. Okay. What's 30 times 116? 3,480. Oh, thank you. Pi, right? What's the unit? Feet per minute. Yes, very good. Okay, everybody? How about if I get 3 decimal places? Like in your calculator. 3 decimal places. What do you get? 1 0 9 3 2 point. Thank you. Yes, feet per minute. Okay, very good. So far, so good, everybody? So we know how to compute the angular speed and the linear speed. Awesome. Okay, final applications. Area of a sector of a circle. Okay. The area A of a sector of a circle of radius pi by the central angle of measured theta radians is given by 1/2 theta r squared. Okay, how do we get this formula? Do you remember for a whole circle, what's the area? Pi r squared. Yes, everybody? So now, let's say this is angle theta. So this is angle theta. You, it shifts. Interesting. It keeps shifting. Okay, I don't want to write on that. I want to write on here. Okay. So the whole circle is pi r squared. Right, everybody? Now our center is theta. What's the proportion of this piece? You know, the whole circle of the angle? 2 pi for the whole circle. Now we have theta. That's why this proportion is theta over 2 pi. Yes. Theta over 2 pi. Oh, do you see the pi cancel? Huh? You? Hey, where is it? Hmm? What? So we get 1/2 theta r squared. Yes, everybody? So we think about the area of the full circle and think about, oh, this sector is how many proportions of the circle? So theta over 2 pi. And then we cancel the pi, we get this formula. So 1/2 theta times r squared. Okay, everybody? Mm-hmm. Now, compute the area of the sector intersected by a central angle of 38.2 degrees in the circle of radius 15.8 centimeters. So first of all, convert the degree to radian. Always do that. Okay, so 180 is pi, right? Do we plug in the calculator here? No, we do it in the last step, right? So area 1/2 theta 38.2 pi over 180. Yes, that's theta. And r, what's r? 15.8, but we square it. See? 1/2 theta r squared. Can we plug in our calculator now? Yes. Give me 3 decimal places. So what do you get? Yeah, so make sure you know how to compute your calculator. What do you get? 83.219. Good. What is the unit? Yes, centimeter square. Yeah, area, you know, for length, centimeters. Area, centimeter square. Volume, centimeter cube. Exactly. So today we learned about how to convert angle from degree to radian and calculating at length, the linear speed, angle speed, and the area of a sector. Okay, so happy Halloween! And see you on Monday. Don't forget to do that. Quiz! Yes! Bye!